Hello students, now we are here with our new topic, redistribution of charges of two different insulated charged conductor or capacitors. So there is but now redistribution, the charge का distribution होना when two charged conductors are connected with each other or when two charged capacitors are connected with each other. Insulated charged conductor mean two capacitors are charged fully and kept isolated with each other. Then they are connected with the connecting wires. Now suppose here we have two capacitors. This is our first capacitor. Let its capacitance C1, charge Q1 and potential is V1. And one more capacitor is having capacitance C2, Q2 be charge and V2 be its potential. And now these are two insulated charged conductors or capacitors. Now they are connected with the connecting wires. Connecting wires से क्या कर दिया, इनको connect कर दिया. Now you know that there is what redistribution of charge means. Suppose if V1 is more than V2, then Q1 charge will flow through the connecting wires to Q2, and if V2 is more than V1, then charge Q2 will redistribute to the capacitor C1 till redistribution of charges from one capacitor to other takes place till potential of both the capacitors become equal. Mean to say that वहाँ पे एक इक्विलिब्रियम स्टेट आएगा जहाँ पे क्या होगा, डिस्ट्रीब्यूशन क्या हो जाएगा, स्टॉप हो जाएगा. एंड दिस इक्वल पोटेंशियल इज नोन एज कॉमन पोटेंशियल. उसको क्या बोलेंगे हम, कॉमन पोटेंशियल V. दिस कॉमन पोटेंशियल. Then this device having common potential V, not V1 and V2. So now we have to find the expression for the common potential. Expression for common potential. So total charge on both capacitors before sharing or before connecting with the wires. Q, that we can write Q1 plus Q2 before sharing when they are not connected with the connecting wires, or we can write C1 V1 plus C2 V2 because Q is equal to CV. C1 V1 plus C2 V2. And after sharing, let V be the common potential. Then total charge is, let it be Q dash, because there is redistribution of charge, the charge gets changed. That Q dash is equal to C1 V plus C2 V, because V is the potential of first capacitor and V is the potential of second capacitor. The C1 is the capacitor that is different for both the capacitors C1 V plus C2 V, and we can write C1 C2 into V. Now since total charge is conserved, charge neither created nor destroyed but get transformed from one capacitor to another, so Q is equal to Q dash. So Q, you know that C1 V1 plus C2 V2 before sharing, which is equal to C1 C2 into V. So we can write V is equal to C1 V1 plus C2 V2 over C1 plus C2, and furthermore we can write Q1 plus Q2 over C1 plus C2. So this is our common potential, and this formula is very easy to remember. That you know that V is equal to Q over C. Q is equal to CV. So here Q be the total charge of the two capacitor, that is Q1 plus Q2, and C the total capacitance C1 plus C2. We can remember this to common potential in this way. Q, that is total charge on the two capacitors Q1 plus Q2, and C the total capacitance of both the capacitors C1 plus C2. And by using this we can solve the numerical suppose. For example, C1 is equal to 1 microfarad, that is 10 raised to power minus 6 farad, and C2 is equal to 2 microfarad, that is 2 into 10 raised to power minus 6 farad. Farad is the unit of capacitance, and V1 is equal to 100 volt and V2 is equal to 50 volt. So we can find out the common potential by using this formula simply. So we write here C1, that is 10 raised to power minus 6, and V1 is equal to 100 plus C2 is equal to 2 into 10 raised to power minus 6, and V2 is equal to 50, and C1 plus C2. So here we can write 1 plus 2 into 10 raised to power minus 6. So by solving this we will get 66.67 volt answer. That is the common potential. So I think this topic is clear to all of you. Thank you. Hello students, now we are here with next concept, loss of energy on sharing charges. You know that in previous topic our theory got redistribution of charge when two insulated capacitors are connected with each other. So there was no loss of energy. So in last topic we understand that there is a redistribution charge, no loss of charge. Charge remain constant, charge remain conserved, but here loss of energy, because suppose here we have two capacitors C1 and C2 and they are connected with the connecting wires. So when charge will flow from any one of the capacitor to the another, or when there is a redistribution of the charge in the system of two capacitors, then there is a production of heat in the connecting wires, because charge will distribute throughout the connecting wires. So जब charge move करता है with respect to time, so there is production of current, and current is the current having a heating effect. Due to that there is what loss of energy. So that loss of energy then we are now going to calculate. Loss of energy in the form of heat in the connecting wires. So now we are going to calculate loss of energy. So here we will use the concept of energy. So and the formula of energy. So electrostatic energy of two capacitors before sharing when they are not connected with the wires, then energy U is equal to half C1 V1 square plus half C2 V2 square. This equation number 1. Because energy क्या होती है हाफ CV square in term of capacitance and potential. And after sharing, let energy U dash, you know that half C1 V square, where V is the common potential. What is V is common potential after sharing, plus half C2 V square. We can write half C1 plus C2 V square. Equation number 2. Now because common potential, simple, Q1 plus Q2 over C1 plus C2, but we are taking the expression in term of CV, then we will change this with C1 V1 C2 V2 C1 plus C2. This is our common potential. Now we will use this in equation number 2. So we get U dash half C1 plus C2, and this is the V square. Put the value C1 V1 C2 V2 over C1 plus C2 square. So this term will get cancelled. One term will cancel with this term. We get half C1 V1 plus C2 V2 whole square divided by C1 plus C2. So now this is our final energy after sharing. But by using the concept we know that this energy is more than that of this final energy, because after sharing there is what loss of energy in the wires. So here we have in denominator we have new term that this value is less as compared to this initial value of the energy. So when we will calculate the change in energy, how much change in the energy, that will be delta U is equal to U minus U dash. So by putting the value of equation number, by using 1 and equation number 4, we get, I am simply writing the end formula or end result by using these equation number 1 and equation number 4 in this value or in this change in energy. We will get change in energy, or we can say that loss of energy. This change in energy is also what is loss of energy, and that will comes to be C1 C2 V1 minus V2 whole square divided by 2 C1 plus C2. You have to remember this formula. And when we will solve this energy delta U, the delta U is always positive, which tells there is a loss of energy after sharing. So this formula you have to remember simply. After calculating equation number 1 and 4, or up to calculating equation number 4, we will write here change in energy and write the end formula. No need to solve, no need to increase the steps. You just remember this formula C1 C2 into V1 minus V2 whole square divided 2 C1 plus C2. So related to this formula, now we have one example that will clear this concept further. So here numerical is a 600 picofarad capacitor is charged by a 200 volt supply. We have a capacitor. Firstly, we have a capacitor and charged with a battery of potential 200 volt, and capacitor has 600 picofarad. It is then disconnected from the supply and connected to another uncharged of same capacitance, uncharged 600 picofarad capacitor. Now this battery is removed. And this is connected with अनचार्ज कैपेसिटर और पोटेंशियल 0 एंड इसका पोटेंशियल कितना था अपने पास 200 वोल्ट एंड कैपेसिटेंस इसकी थी 600 पिकोफैरड and this is also 600 picofarad connected with the same capacitance of capacitor. So how much loss of energy? You know that its potential 200, its potential is 0. Let it be V1 and let it be V2. So V1 is 200 and V2 is 0 because it is uncharged. So there is what redistribution of charge till the potential become common, and through this there is a loss of energy in the wires. So we will do simply, we know that we will use the formula. We know that delta U and U minus U dash, that is what loss of energy after sharing is C1 C2 V1 minus V2 whole square divided by 2 C1 plus C2. Now because C1 is equal to C2, that is equal to 600 picofarad, and picofarad that is equal to 10 raised to power minus 12 farad. V1 is equal to 200 volt and V2 is equal to 0. Only these values we required and we will use in this formula. So simply you put the value C1, that is equal to 610 raised to power minus 12, V2 also 600 into 10 raised to power minus 12. Simply you firstly simplify this equation, simplify it, then it become very easy to us, because C1 is equal to C2. So we will write here C1 square V1 minus V2 square, and here 2 and C1 plus C1, that become C1 square V1 minus V2 square, and here it become 4 C1, it will cancel, we left with C1 V1 minus V2 square over 4. Now C1, in this formula we can calculate delta U C1, that is equal to 610 raised to power minus 12, V1 200, V2 0 whole square divided by 4. So this is equal to 610 raised to power minus 12 into 4 into 10 raised to power 4 divided by 4. So we will get 6 into 10 raised to power minus 6 joule. This is the energy. So I think this expression is clear and easy to understand. Thank you.